is known for his work on Python. He's written the Python Cookbook and other books on Python. He's currently Google's Uber technical lead, and he's won many awards for his teaching and his technical achievements. So, Alex Martelli.
Yep. I need to correct one bit. I used to be the Uber Tech lead. Now I'm a senior staff engineer. I switched from management to engineering, which is quite encouraged at Google. It's an amazing thing, let me tell you. Many other places, once you pick the management track, that's it. Never going back. It's different for us. So anyway, why Python? This is the main reason, of course. I gather this guy is well known around here, and unfortunately I can't do the yellow sticky notes, so I just copied the text from the yellow sticky note to the side of his great cartoon, which, by the way, is all-time top vote getter on Stack Overflow for best programming cartoon ever. I think it's pretty close. So, what do I mean proficient programmers? I mean you have some programming experience in some typical language such as Java or C++. You have a little Python. I did mention that to the organizer. I think I'm not going to go through the tutorial. You can perfectly well do that yourself online. It's very, very easy. And on the other hand, if you've been using Python for many years, it could be kind of boring in some parts. I apologize in advance. A little app engine, just having gone through the Hello World exercise would help a lot. A little mixed stuff, design patterns, agile methods, and so on. And also, my code is very succinct because I want to fit in one slide every single idea. So the style isn't exactly ideal. I apologize. In graphical terms, in my favorite terms from the No theater and also adopted in martial arts and other disciplines, the Shu, Ha, and Ri phases of learning, where you learn by rote, start detaching from your learning, and finally transcend learning. I expect not all that much in terms of Python, Google App Engine, agile methods, and so on. I do expect a lot in terms of general purpose programming skills. So Python is a very high level language. This is a technical term. It also applies to Perl, Ruby, all sort of languages that basically take a higher abstraction view, not necessarily dynamic ones. Haskell is one too. What distinguishes it most is its clean, spare syntax, following Toothtips principles. I'll mention those later. Simple regular semantics, multi-paradigm based on an object-oriented foundation, and its focus on some qualities which not everybody recognizes as strength. In particular, there's a lot of people who think uniformity means irregimentation. It's not so, but definitely Python focuses on that. A reasonably rich standard library. I used to say a very rich standard library until I took a gander at the amount of docs for Java standard libraries today. Is okay. Reasonably rich, not too rich. And all the rest comes from third-party open source extension and tools. And the implementations are all open source, and they're very strong. One thing I'll be doing in some of these slides is just show faces of people who have contributed. They're not necessarily the top contributors, but it kind of connects us to the fact that, yes, this is software, but software is all about people. The reference implementation, CPython, is probably still the best known and the best quality in many respects, but Sun, the open source program Jython, which is now supported by Sun, is very close to it. Microsoft's own Iron Python in certain aspects is superior. It's also Microsoft's first complete product released on an open source license, OSI compliant license. PyPy is still kind of experimental, but is getting to 1.0 and later. And it's characterized by being able to compile Python for multiple backends. Some are really well supported, like LLVM for machine language generation. Some not so much, like JavaScript, which is kind of like more of a game. And Nokia's Python is finally usable on S60 phones if you happen to have one. There are many other variants which are not yet production ready. For example, Alison Randall is doing Piney, which is a Python compiler for the Parrot virtual machine. It's unusual in not targeting the widespread Python 2.5. She aims right for the 3.0, 3.1 levels because they're so much simpler. They have removed a lot of redundancy that's accumulated in the 2.star series. There's Python D, which can not really go beyond 2.4, but runs great on a DOS machine. If you have any DOS machine with 64K of RAM, that's your best bet. There's Unladen Swallow, another open source project, this one strongly supported by Google, to make a faster, better Python 2.6. There are variants such as Cython and Boo. There are lots of excellent books. You know what they say. Outside of a book, a man's best friend, outside of a dog, a man's best friend is a book. Inside of a dog, it's too hard to read. So as long as you stay outside of the dog, I should probably recommend just a few. If you want to start with an introduction that treats you as smart, experienced programmers, despite the title, Python for Dummies is great. Core Python Programming by Wesley Chan is probably even better, beginning Pythons. At more advanced levels, Python Cookbook covers a widespread term. Of course, I'm biased because I did it with my wife. Python in a nutshell, I did on my own, so that's not quite as good. Python Essential Reference, David Beasley. And Iron Python, one of the big strengths of Iron Python is it comes with an absolutely awesome book. Iron Python in Action by Michael Ford. If you know Python and want to learn something about .NET, or if you know .NET and want to learn something about Python, either way, it really has you covered. Great book. And of course, there's plenty of online resources thanks to these guys. My favorite ones being search engines, of course. But there's plenty of books. There's this site, which is by far the best Q&A site. It doesn't just cover Python. The tags cover everything. It's particularly strong in .NET. As Randall Munro said in the opening comic, to say hello world, you just print hello world. To do hello world in App Engine, exactly the same. You make a hello py file with that line only, and then you write a little configuration known as app.yaml, which basically says whatever URL, handle it with hello py. Hello py doesn't do much handling, it just emits a line and that goes to the browser. In Python 3, the biggest incompatibility with Python 2, you need parentheses around the hello world because print isn't a statement anymore. It's now a function, and to call functions, you need parentheses in Python. So why is it important that hello world is just one line? Because it supports low ceremony programming, one-off script, throwaway script, exploratory programming, even interactive programming, rapid prototyping, no requirement for tools to compensate for a language that isn't suited for it, for declarations. The only declaration I did in my life was to my wife. I did a declaration of love. I don't need declarations in programming. Although I love Python, I don't need to declare it. It knows. So when you want to just do it, low ceremony programming is exactly what you want. But note that the fact that the language supports low ceremony programming doesn't mean it doesn't support large system. Except the language is not imposing process and discipline on you. You have to impose them on yourself. The team as a whole must just make decisions to do things the right way, the high ceremony way, if needed. Use linting, use unit testing, use code reviews, avoid certain constructs that are only there to support low ceremony, fast, quick and dirty programming. It basically, Python leaves the choice, high or low ceremony, up to you. It definitely supports extremely large systems. We've got plenty of examples of those. So, I did mention that I hope you have some experiences in languages such as Java, because Python is a lot like Java. In both cases, the typical implementation is a compilation from your sources to bytecode. and then that bytecode is run on a virtual machine or runtime system, question of terminology. Two biggest differences is in Python, compilation can be implicit. You don't have to explicitly use compile.py to get your source into executable form. You can just let the source laying around, and it will get compiled as it's needed. Now, one of these two ways is high ceremony. The other way is low ceremony. Anybody got any guess at what way is low ceremony? That is, you can do both, but anybody think that running explicit compilation paths is low ceremony? Anybody think that just doing it is high ceremony? So it's pretty clear. If you're just hacking on it, you never explicitly compile. You just find out after a while that all of your source directories are dirtied up with .pyc files that you didn't put there. No problem. That's Python put there for you. If you are in high ceremony with a release branch and release steps and so on, you can perfectly well build it in an organized way. The other, so the fact that it supports both high and low ceremony, to my way of thinking, is a big plus for Python. The big minus for Python is our just-in-time technology is far from mature. While Java's is very mature, we're basically just starting to really try it out. There's a little thing called Psycho, which works for Python 2-star only, and only on Intel x86 machines. So it does a pretty good job for it, but the unladen swallow aims to JIT. PyPy is a lot about JITting and so on. Just like in Java, in Python, just about everything also inherits from object. But in Python, everything means numbers. There's no primitives that don't inherit from object. Functions, classes, they're not declarations you do to the computer, see before. They're objects like anything else. And so they inherit from object. There's no boxing or unboxing. Everything is for class. Everything is on the same plane. Like in Java, the semantics of assignment, argument passing, value returning are uniform object reference. So if you know Java, I don't have to explain. If you only know C++, this will give you a nightmare in either Python or Java because you expect things to be either by value or by reference. And in Java and in Python, they're both and neither. It's an object reference. They both have garbage collection. There's subtle implementation differences. Python traditionally used reference counting, which is nice as long as you're single-threaded, but really hampers the implementation when you go multi-threaded. But of course, it doesn't mandate that as a language, because otherwise it would be a nightmare to bring it onto .NET and JVMs and so on. They both have large libraries, abilities to introspect objects, serialize object, dealing with threads, and so on. But also, Python is a lot like C++ because it's multi-paradigm. It's not a force-fit object-oriented programming where basically you have to put everything in classes, even if the classes have absolutely nothing to do with what you want to write. You can write procedural. You can have a little bit of functional programming support, though not as much as you get in a full-fledged language like Haskell, but say on a par with Scheme, roughly, which is also a multi-paradigm language. Does functional pretty well, but it doesn't force it on you. And generic programming, which is basically signature-based polymorphism. In C++, you have to have a lot of craft, syntax craft, to do the templates. In Python, it's automatic, but the concept is very similar. The operator overloading is very, very similar. In Python, you can overload some extra operators, like looping, but you cannot overload assignment, because in Python, assignment is not an operator. That's a pretty deep difference. In both languages, there's no preferred GUI or web toolkit or network stack and so on. These are absolutely crucial choices, but both C++ and Python let you entirely free to make them all. Spiritually, however, Python, of all the widespread languages, is the one closest to C, which surprises people because it's all different. It doesn't have braces. Well, you guys are a bit too grown up to remember, but as younger teens, you may remember how much better life is without braces. That's the main inspiration for Python, really. My good friend Bram is trying to broach a compromise whereby you close braces but never open them. But I hope you caught his talk on Zimbu. If you didn't, visit zimbu.org. It's a really interesting language. But back to the spiritually most like C. The point is that the spirit of C has nothing to do with surface syntax. There's a section in the ISO C standard preface, non-normative, called the rational, which explains exactly what is the spirit of C. It's made of 5 points. Trust the programmer. Don't prevent the programmer from doing what needs to be done. Keep the language small and simple. Provide only one way to do an operation. 4 out of 4, Python matches perfectly. 5th, make it fast even if it's not guaranteed to be portable. We're not exactly there. But how can, if this is the spirit of C, how can any language with the keyword private possibly be said to in any way resemble C? It goes out of its way to prevent the programmer from doing things and not trust it. How can any language with a amount of size that C++ has grown to be considered to be one of them? Maybe it's not a coincidence that the people who were most motivated to make C happen, the guys who come from Bell Labs, one and all dislike C++ intensely. Even though it's got basically identical syntax, it's a totally different language in spirit, while Python is pretty close. By the way, this is something that only C and Python among widespread language, and I was happy to see the new Zimbu language adhere to. Deliberately providing more ways than one to do something is wrong. It's a design ideal. Of course, you'll always let people write A plus B or B plus A with the same meaning if they're numbers. Oh well. But philosophically, we'd ideally like to have a single way to perform an operation, because anything else just makes the language bigger to no good purpose. So, harping back to the idea of high versus low, if you open the SDK, the application engine SDK, and ask it to make a new application for you, it generates a lot of code, and this is the gist of the code it generates for you. This is a Hello World application. However, it's obviously much higher ceremony than the print Hello World approach. It has imports, it has a class, which inherits from something, defines a method, it has a main, it builds some object and runs the handlers over this application. And it conditionally executes the main if this is indeed being used as main. Why would we want to do all of this when we could just print Hello World with the identical effect? Well, if the whole purpose of your application is to print Hello World, I agree this would be totally silly. However, I'm sad to inform you, there is really very little commercial market for applications that do nothing but print Hello World. You typically, yeah, I know, the customers are so demanding, they typically want a little more. So, why? Why do we put in the ceremony? Because this affords a very nice two-level organization. Your configuration file, app.yaml, dispatches the URL to the appropriate module based on regular expressions. And then within the module, you have a similar structure which dispatches within the module two different handlers, again based on regular expression matching. The fact that you're following the def main and so on conventions allows App Engine to optimize the execution of your application a lot if your application gets a reasonable number of hits, because When it loads the model as required by AppYAML, it recognizes there's this main function that gets executed, and then it assumes that this is, by convention, that this is doing all the preparation you need. So unless it needs the memory for something else, it's going to keep it to keep it in memory for you. So when somebody else visits your application's URL, it doesn't have to do any reloading and so on. It just hits the already in memory copy. So that's a huge performance advantage. But moreover, over and above the performance issue, by the two-level and class organization, you can partition your application, you can structure it, you can afford better maintenance of it, you can layer it, you can partition it in different horizontally distinguished functionalities, and you can layer each into storage, business logic, and views. It supports better team processes, better management, iteration, cooperation, adaptation. Higher ceremony doesn't mean your software becomes rigid. On the very contrary, the higher ceremony software, when done well and in conjunction with good processes, is easier to maintain. It's more flexible. And don't forget that when all you need is prototyping, you still have it at hand. You don't have to make a philosophical choice for life, one or the other. In Python, you get both. So I earlier tried to give a short summary of what Python is all about, but this guy, Tim Peters, did it better than I did. His official explanation for this is that he had a beer too many. But I think he did a great job, to the point that my wife and I had this among the readings at our marriage. We met through Python. That kind of helps. Beautiful is better than ugly. This is about the looks of your program. Explicit is better than implicit. Another highly controversial thing. Python doesn't stop you from doing things implicitly, magically, and under the cover, but it doesn't not particularly happy with you when you do. Simple better than complex, and complex better than complicated. Flat better than nested. So for example, if you have a loop that's structured like if this, then do something, and then if that, then do something, and then if, when you have 3, 4, 5 level of indentation, you're doing it wrong. The right way, if not this, continue. Do something. If not that, continue. Just go out of the way as soon as you know there's nothing more. Stay flat. That's very good. It makes your code more readable. Special cases aren't enough to break the rules, but practicality beats purity. Python is not a purist language. It's not a minimalist language. It's a highly pragmatic language. Errors should never pass silently. We've had a great talk on JavaScript before dinner, which unfortunately passes silently most of your errors, which is its worst defect. Unless explicitly silenced, you have to have a way to intercept errors and make sure they get handled without disturbing the user. Refuse the temptation to guess. If you don't know what's needed, don't just guess one way or another, find out. This is the point of focus where we are just like C. And the fact that the one way that's obvious may not be obvious unless you're Dutch is, of course, a reference to Guido's ethnic origins. Now is better than never, but never is often better than right now. This is about lazy execution. If the implementation is hard to explain, it's a bad idea. This is hard to explain to other programmers as opposed to the general public, otherwise we'd never get anything done. And namespaces are one honking great idea. So let me give, this is my favorite example of some feature which helps low ceremony programming being a disaster whenever you're trying to do things right. From tk import star. Is that okay? If you're typing at a terminal, typing at the interactive thing, sure, it is. Because this way you won't have to say tk.this and tk.that, and you type much faster. In a real program, it's a disaster. You're destroying the namespace. You're polluting your namespace. You're breaking the last and most important point of the spirit of Python. Namespaces are one honking great idea. Again, Zimbu has learned this lesson so that when you import something, you get a top-level name always. It actually doesn't support low-ceremony programming where you get everything from inside that thing. You always have to use a qualified name. In Python, you can go low-ceremony, use the import star, but don't come complaining to me if you get confused about, okay, this name, where did it come from? I don't know any more than you do. Just import the top level. If you want to ponder and meditate again upon these important things, just do an import this from any interactive prompt, as long as it's a Python interactive prompt. So, on the basis of all this, given that I started by claiming similarity to C++, Java, and C, what are the real differences? First, types are strong but dynamic. This is also a huge difference with respect to languages such as JavaScript. If you have a string which just happened to be the digits 2, 3, 4, and you add 1 to it, the number 1, what happens? Well, in the statically typed languages, the compiler will slap you because the operation, there's no defined operation plus between a string or a constant star or however they will call it in an integer. In sloppy languages, you will get either a string or a number. Your guess is as good as mine, which instead of the digits 2, 3, 4 has 2, 3, 5. Python is neither. Python has strong typing, but the types are active at runtime, not at compile time. So you will get slapped by the runtime. You will get an exception for trying to do this addition. So for aficionados of the other two styles, of course, this means the worst of both worlds. For me, it's the best. Duck typing, absolutely crucial, and essentially the same low ceremony name for signature-based polymorphism. I think it's duck typing sounds better. No declarations. So another important case. They're kind of out of, or there used to be declarations of war. Now people just go and shoot you. So they are getting into the spirit. Spare syntax, no ornamentation. This is what I call Toothtips principle. Although he didn't actually put it in words, but it's my summary. Don't waste a pixel. So in a sense, I'm violating it by this ornamentation, but I think it's cute, so it's not exactly wasted. While braces and parentheses and so on, and punctuation in general is not really cute, unless you're doing ASCII art, in which case it's really precious, but if you're doing programming, it just kind of stands in the way. And everything is a first-class object. So this is my favorite way to explain duck typing. Just imagine you could teach ducks to type. That would take you some time to teach them to type, but how much time would then you save? So this is why we focus so much on duck typing. We've identified the ducks so far, not quite trained them, but we will be. Unless the monkeys get there first, of course. But we bet on the ducks. So, simple types are all immutable, just like in Java. There's numbers and strings. There's a variety of numbers. It's actually a very precise number system, complex, float, and so on. Strings are Unicode and bytes. Actually, in Python 3, everything has been simplified. Strings are Unicode now in Python 3, just like in Java. And just like was always the case in most Lisp implementations, integers are integers. You don't have to keep track anymore of whether it's a short integer or a big integer. It's much simpler. You get all the usual bit twiddling operator, arithmetic, and so on. The one difference is that the precedence actually makes sense. I know that's pretty revolutionary, but it doesn't have to stay compatible with wrong design choices about operational precedence. There's a lot of method for strings. You can look them up in many ways. If you're in low ceremony mode interactively with help string method, if you have a good installation, or just a dir, and don't be frightened by all the stuff with double underscores. We'll get to that. Container types, there's a small set, but plenty sufficient, tuples list, sets, frozen sets, dicts, and they all try to operate reasonably consistently. They all have a length, all support looping on them. You can test for membership. These are basically the operations that make sense for any container, not many others. Some containers are sequences, so they are in a certain order, in which case it makes sense to talk about repetition, catenation, indexing, slicing. Every time we slice, or loop for that matter, start is included and end is excluded. This is a principle that, to my best of my knowledge, was first put in writing by Andrew Koenig in C Traps and Pitfalls, something like 30 years ago. Lists are mutable sequences. So, for example, you can slice string, but this will give you another and just as immutable string. But if you slice a list, you can assign to the list, to the slice, which changes the sequence, changes the list. So if you assign a longer list, the sequence becomes longer. If you assign a shorter one, it can become shorter. Again, containers, they have mutating and non-mutating methods, which often confuse people because mutating methods return none. People expect mutating methods to return the very object they just mutated so they can do chaining. We, for once, respect Bertrand Meillet's principle of common query separation. Don't confuse queries which return a value and ideally don't have any side effect with commands which you are doing only for their side effects and return no value. That being said, Python is pragmatic, so a few obvious cases such as popping something from a container actually returns you the value you just popped, as opposed to the container. At least you never get the container back. That's helpful. There's a variant of dict. There's a module collections, which is absolutely typical. And this is another thing that grates for somebody. There's no heap type. There's heap functions. There's functions that let you treat any list as a heap. There's a module heap queue for the purpose. So another example, how do we make a heap? Here's a heap class in 10 lines. So the title sounded so good that even though it only took me 9, I decided to let the title be a lie. It includes the import, of course. It subclasses list, so it only needs to add the functionality that heaps want. It needs to explicitly delegate initialization, and then call a rehappify, which is just the heapify method of function of heap queue, and then it got push, get min, and pop min. I mention them this way so they have nothing to do with a pop method and get method of other containers. This is not a robust production-ready heap. It's low ceremony. It's something you can hack together in 2 minutes. Anybody can spot the crucial defect. The crucial defect is the breaking of a principle outlined in one of the books that are visible in the glass things at the entrance of this building. Prefer composition to inheritance. That if you've read through all design patterns and retain only one sentence, retain this one. Composition is better than inheritance. If both are an option, you should pick composition. This one picks inheritance. And so, inheritance never lets you take anything away. There is absolutely no safeguard against a little mistake whereby somebody takes what you've so carefully made a heap and appends something. If you inherit from list, the append method is available, and that breaks the heap invariant. And you cannot take away the append method because it makes no sense on a heap. So this means a heap is not a list. The is A doesn't apply, so you shouldn't inherit. Prefer composition. You should not inherit, just inherit from object, and keep the list in your object, and almost everything else is identical. So you'll just use self data instead of self. You will have to explicitly delegate to list certain things. For example, the length of the heap is the number of objects currently in the heap is exactly the length of self data. So with inheritance, we saved a few lines by not having to have explicit delegation of such things as len, iter, contains. Now we have to do that, but it's a reasonably small price to pay for the robustness of all this. Okay, another interesting, relatively new thing in Python is one of the best implementation of one of Björn Strausstrup's best idea, known as resource acquisition is initialization. Basically, when you acquire a resource, you want to make sure you give up on it when you're done. How do you do that? Well, there's try finally, but as every Java and Python programmer knows, it's kind of a mess. In C++, you can exploit the fact that a certain variable can have a stack lifetime, so basically a block lifetime. So it gets a constructor at the start of block, and no matter how the block is exited, the destructor will run. And so you pair basically the open paren is the constructor and the closed paren is the destructor, and you have the guaranteed acquisition in initialization and release on finalization. In Python 2.5, if that's, for example, what you're using, if you're using App Engine, you need to use the peculiar Python construct from future import. When we introduce new keywords, for example, new things that might break existing programs, we put them there, but in the future module. So you have to import them explicitly if you want to use it. And then one release later, we just make them keyword. It's impossible for some program to break in a one release move, although a two release jump may destroy it. So the idea is you do a with expression as name. This basically takes the expression as a context manager, executes its enter method, which is different from a constructor, so you can specialize much better. And then at the lexical end and exit from the controlled block, the exit method, which is also better than the C++ situation, because the exit method gets informed if there has been an exception, what exception it was, or if it was a normal termination. So, for example, differently from C++ construction, with is perfect for a database scenario where you are transactional. Your exit method can very naturally do a commit work if you're exiting correctly, but do a rollback if you're exiting due to an exception. And then we have my homage to Haskell Curry, iterator and for loops. The simple seeming construct for I in C can actually be expanded. In this case, the expansion is purely conceptual. It doesn't, in this case, it wouldn't give you any advantage to actually go and expand it. But basically based on obtaining an iterator on the object and stepping through the iterator until a stop iterator gets raised. The fact that these underlying mechanisms are all exposed empowers you to do extremely powerful stream-based programming on iterators. Another couple constructs are generator expressions and list comprehensions, which together are about the same power as Haskell's list comprehension. Haskell is an intrinsically lazy language, so it doesn't need to distinguish construct me all the list at once versus do it only as required. Very strong but hard to implement stuff. So we have a non-lazy, normal, eager language, and so we have the distinction there. Examples of GenExp, they make so much code so great. For example, counting something means one for each thing in it. That's it. So, for example, count the x's in range of 99 who are the same modulo 5 and modulo 7. Sure, you could develop the arithmetic formula for that, given a range of numbers and two possible modulos, how many have the same remainder. Just count. It's simpler. There's such construct as any and all that check, do as little work as possible to check everything that's contained. So if any x is greater than 5 for any of the x in x's, do something. The higher conceptual level versus loop over the x's. If the current one is greater than 5, then do something and break out of the loop. This is just one level of abstraction higher. Similarly, this is using the fact that comparison chain. So if x greater than y greater than z has the natural meaning, x is greater than y and y is greater than z, exactly like it would anywhere in mathematics. The maximum is similarly going to be applicable there, and so on. Generators are functions that use yield instead of return. What that means, yield means provide a result but suspend execution at this point because it can be resumed. So it's like half of a coroutine, if you're familiar with or 1/3 of a call CC, if you're familiar with call with continuation. It's basically the easy part to implement and the most useful part to actually use. So for example, if enumerate was not a built-in, this would be a very simple way, this generator would be a very simple way to implement it, because basically the state is held in n, and n keeps being incremented as the item that of the sequence you're enumerating is gotten, and they're yielded together, and then you keep incrementing. It's very easy, of course, to make a generator that's endless, like Fibonacci numbers, which, as you may know, were introduced by Leonardo Pisano, nicknamed Fibonacci, as a problem in a textbook. Suppose a little farm has only two rabbits, but every year, anyway, basically, there doesn't have to be a termination. It will have to be imposed externally in this case. For example, here I'm imposing it with, well, if I have more than 100 rabbits, I'd better stop, sell the farm before they overwhelm me. Closures, which were quite correctly highlighted in the JavaScript talk before dinner, are also perfectly available in Python. Basically, it's all about exploiting the fact that creating a function, def, is not a declaration, is a statement. It does something. What it does is create a new function object, and also there's a lexical scoping, so every free variable accessed from containing function is kept. So, for example, you can make others, which confirms Python's familiarity with reptiles. So A23, for any argument, will add the number 23. A42 will add 42. You can apply both. They are completely independent and stateless. Properties are essentially what stops you from having to write getters and setters method, because at any time you feel the need to add a getter method, you can dress it up as attribute access. Operator overloading is where the double underscores come from. It's not the ideal solution. All of those double underscores, if you do a lot of these kind of programming, are kind of ugly. I believe I first saw this choice, essentially stropping names to make operators in a little-known language called Sather, a dialect of Eiffel. The point is you're supposed to only define this and never call them yourself, or hardly ever. You can overload all sort of things. For example, there's both a new, which is a constructor, and an init, which is an initializer. You rarely need to define the new, like in C++. There's an operator new, which basically is the one actually doing the building, and then there's what C++ calls a constructor, which initializes it. This is not exactly a destructor, but kind of similar. You can overload all the comparisons, arithmetic, all the operations such as hashing, calling. I did mention, for example, there's no hashing operator in C++, so you can't overload that particular one. But then again, we don't have assignment, so let's call it even. Attribute access, that's another thing that you can't overload in C++. Enter and exit are used with the with statement or the context managers and so on. So this is another way to make an endless iterator. It works exactly like the one I mentioned before, except it needs to initialize, basically keep state as a variable, define explicitly that when iterating it returns itself, and define the special method that defines an iterator, that is how to take the next step. This used to be called next without the double underscores, kind of a design mistake. It's now officially a special method, as it's always been. And so this works exactly the same. Let's take this as an example to reflect that higher ceremony isn't necessarily better. I mean, compared with a 3-line solution before, this one doesn't give you any extra value at all. But most of the time, the generators will be there. But whenever you find yourself wishing for just one more little feature, thin mint in generators, this is what you should be doing. If you need more than the generators can give you, this thing is perfectly customizable. It can give you absolutely everything you want. The point of making the special methods ugly was maybe not the best design decision ever, but it was a design decision because it's intended to signal that you shouldn't be calling them. Rather, you should be calling built-in functions and operators that rely on the special methods but may add logic. For example, to get the absolute value of a number, never call its dunder abs dunder method. Dunder stands for double underscore, which is kind of long to pronounce. Call abs with the number. For all you know, an implementation could first see if there is an available dunder abs. But if there isn't, fall back to comparing the number with 0 and possibly changing sign if needed. The point is that they built-in can add value compared to the bare functionality. Think of it as a kind of extension of the template method design pattern. There's plenty of interesting functions that are built in. I already mentioned abs. I showed any and all kind of rapidly earlier. But really, these need to be looked up. The choice of what is and what isn't a built-in is always a bit delicate. Indeed, one of the changes from Python 2 to Python 3 was remove some of the built-ins to the standard library because they're not used that as often as to need to be built in. You can perfectly well afford to require an import before they're used. And from any other viewpoint, the built-ins, the near built-ins that are actually in the standard library are just as good as the ones you don't even have to import. So talking about modules, the point is it's very easy to make a module. Any source file, something.py on the syspath, any directory with a dunder init.py file, they could be in zip files too. A zip file you can directly import from. And also you can add hooks that lets you import from other things yet, like a database or something. It's pretty strong mechanics to support that. Also, in Python per se, modules aren't just source units. anything that's been byte compiled or compiled all the way to native code with any of the several available approaches is also importable as a module. So App Engine constrains that. You basically have to upload the .py in order to be able to import it in App Engine. That's a specific limitation imposed by App Engine, not a Python limitation. Once imported, a module is a simple object with attributes that you can get and set, although it's pretty weird to set a module's attributes from outside, known as monkey patching. You can do it, although I don't recommend it. There are generally better ways to do it. But it's intrinsically a singleton, so basically you normally don't use the singleton design pattern in Python, because when you need a singleton, you do a module. If the module gets imported several times, only the first time does it actually get loaded in memory. Every other time it will be looked up in dictionary sys.modules. So basically you just get the one existing instance, and so it's a singleton. However, it's not a class instance, so you cannot do operator overloading and the like. When you do need to treat as a module something that is not a module, so basically you can exploit its singletonness, what you do is in your something.py, you define a module-like class and then stick into sysmodule under the current module's name the one and only instance of that class. The first importer of this something.py, this will execute, and then the sysmodule of names will be returned, so it gets to use the class instance as if it was the module. Everybody else will just reach for sysmodule and use the instance. Used to be, batteries included used to be one of Python's mottos, but actually the standard Python library has only about a couple hundred modules in addition to many more that are basically tests, codecs. The variety of codecs never ceases amazing me, and demos. So a couple hundred modules are what typically you will be importing from the standard library in your Python project. Some are pure Python, some are C++ coded, some are C coded, sorry. And some are both, as in we have typically one pure Python version which tries to import the C version for speed, otherwise it just does it in pure Python. In App Engine you will find all the pure Python modules and most of the standard library modules that are traditionally implemented in C, with a few exceptions. You cannot open an arbitrary socket, you cannot generate a new thread, so sockets and threads are modules that are not available in App Engine, for example. And of course, App Engine will add its own always available modules, packages, and so on. And also its own functionality like the data store, users handling, fetching URL, sending mail, and a few open source libraries such as Django that are so popular that instead of asking everybody to upload their own, we make them available for a simple import. So I've been asked to estimate how long it would take an experienced programmer. I was typically being asked by some company executive back when I was a freelance programmer selling my services as a Python consultant. How would it take to train my experienced people who are strong COBOL and RPG programmers to use Python instead? The language, 1 to 4 days. Depends on what the background is. If it's COBOL, will be more like 4 days because so many concepts like object-oriented are totally new. If it's Java or Perl, more like 1, and something in between. But that's just the language, which per se, while very nice, is not what you use every day on the job. You also need to understand all the built-ins, the special methods, iterators, generators, meta-programming, and a few more things like context managers. That's going to be another 2 to 4 days. Again, depends on the background. Oh, but then you don't really want to like ignore the standard library, right? So the standard library is so useful. You want to give it some time. Well, there's some absolutely core modules that you need to understand inside out and have like always at the top of your mind. OS, all the operating system functions. Sys, all the system-specific functionality. RE, regular expression. Struct, packing and unpacking bits. Iter tools makes your iterations much more powerful and faster. Collections adds double-ended queues, dictionaries with defaults, all sort of cool stuff. Abstract base classes, which I haven't really covered because they're rather new thing in 2.6, but are really cool, and so forth. Array, very compact, homogeneous arrays. At exit, how you register stuff to make sure it executes on termination. Math, all the mathematical operations. Pickles, realization. String I.O., they reverse, treating a string as if it was a file. Heap queue, we mentioned that. Weak references. If you're not dealt with weak references before, that one will probably take more than all the others. Threading, same. Queue, multiprocessing, and so on. That will be 2 or 3 weeks. So 10, 15 days is in business days. To get a complete grasp of all the standard library will take about 3 times as longer as just the core modules. And then you start on the tens of thousands by now of third-party modules. And here I refuse to offer a projection because I suspect that when one is finished learning everything that's available today, the stuff will have just doubled, so the task will never be finished. Just because Python programmers are so creative, they keep uploading stuff to PyPy. But then, this isn't just Python. What does it take to learn everything about software development? I mean, many of you guys are studying it, so you may have an estimation. Well, my estimation is as follows. Know everything there is to know about algorithms, data structures, mathematics, probability, considerations such as big O, programming paradigms, just the most important ones, procedural, object-oriented, functional, generic, declarative, relational, a vast number of languages, libraries, frameworks, dialects of languages, because you can't program in MySQL and Oracle SQL in the same way. So they're one language, maybe, but they're practically 2 dialects you have to learn. Design principles, patterns, idioms, pitfalls, system architectures, platforms, databases, networks, protocols, parallel programming, interprogramming communication, testing, agile methods, other methods for comparisons, capability maturity model, for example, planning, estimating, user experience, user interface issues, internationalization and localization, and I'm not even getting into specific application areas. The fantastically challenging issues of managing software development and so on and so forth. Well, I think it takes several lifetimes, definitely more than one. Which is good, I guess, because it kind of guarantees me, makes me safe inside that I'll never feel like my homonym was said to feel after he had finished conquering India. He didn't actually. He got pretty close, but he didn't actually conquer much there. And it was sad because he had nothing left to conquer. I'm pretty sure that even with Python to help, I'll never feel sad because I have nothing more to learn. And that's it. I am refreshing because I'm sure nobody jotted it down in the first place, the URL for the PDF for this presentation.
At this point, if you guys have any questions, just raise your hand and I'll run up to you.
I actually have 2 totally unrelated questions. The first is, you mentioned the from future model, but you also mentioned that there were some deprecated internal functions. Is there anything special that you need to do in order to validate that your 2.6 code will work in 2.7 and that you're not still using keywords that have disappeared?
So nothing will disappear within 2-point star. Python's backward compatibility guarantees if you are running something that gives you any problem, it will warn. The incompatible step, potentially incompatible step, is in moving from 2 star dot anything to 3. Python 3 was a deliberate choice to rid the language of redundancies that had accumulated and that couldn't be removed without introducing some backward incompatibility. So it was done. Limited backward incompatibility, but quite some. For that specific purpose, you run your program under Python 2.6 with the explicit flag, I think it's called -3, meaning warn me if I'm using anything that will be a problem to translate to Python 3. And then you run a translation module that is supplied with Python 2.6 called 223. It actually, there's a more recent version that comes with Python 3.1. Should use that one. And that does a code translation of your code in cases where it can be done automatically. For example, if you have print space x comma y, you don't have to go in yourself and insert the parenthesis after the print and at the end of the line. The 223 code can perfectly well do it for you. It's pretty trivial. So what the -3 switch is telling you is there are some cases where 223, which is a rather simple program, cannot tell exactly what you're trying to do, but suspects it's something that may break in Python 1, and so you may want to rephrase. Basically, they typically suggest ways to express things so that they can be translated unambiguously or work in both releases. But within the 2-point star series, no problem.
Okay. I have a second question. And then my second question is, I thought you had something in there about abstract classes. How does that tie in with the philosophy of always letting programmers do whatever they want in order to not limit them?
So the philosophy is to let programmers do what needs to be done, not whatever they want. There's a difference. Okay. Abstract-based classes are an additional functionality that allows you to do things that need to be done in a much nicer way. For example, if you have an object and need to find out whether you can loop on it, you can check if it is an instance of iterable, the abstract class iterable. What that means, the abstract class iterable implements its own check instance, and it does the check that there is a next method, which is what you would normally have to do otherwise. But it's much nicer. And you don't have to worry about how is it that the abstract class iterable performs a check of whether that thing is an instance of itself. Maybe, I'm not sure exactly what you think abstract-based classes are taking away from programmers, because it's absolutely nothing. They only offer a better, an obvious way to do things that previously had to be done in less nice ways. Another example, instead of requiring mix-in functionality, take some interface that's very rich, like dictionaries. Dictionary offers 50 methods. So if you want to implement a mapping that's compatible with dictionaries, do you have to write out 50 methods? The point is not necessarily. You need to have a few key methods, such as crucial methods, such as give me the list of all keys, and given this key, give me the value, that kind of thing. And all the richest methods can be implemented on top of those with a template method design pattern. You can override them if you have a faster way to do them, but you don't have to. In Python 2, there's a mixing class to support that, but in Python 3 or 2.6, you get that much more easily by overriding the subclass method of mapping. Mapping will give you all that functionality if you are not explicitly overriding it. So it's not really taking away anything from you, it's sanding.
I've used stackless Python a little bit before, and I was wondering if you, is stackless generally just kind of considered to be a cheap hack on top of Python, or is it considered to be illegitimate?
I believe stackless is still maintained. If you want to help it become a strong standalone product in its own, I suggest you look into Pynie, P-Y-N-I-E. I mentioned it briefly in passing. It's an experimental effort so far to implement a Python compiler for the Parrot virtual machine. The Parrot virtual machine also pretty close to having a good Perl compiler, JavaScript one, and a few others. Parrot is stackless. It uses essentially the concept of a list of frames, and so fully implements callcc. Stackless never really had a complete callcc. If you're not into scheme, then you probably don't get what I'm talking about. But you should get a little scheme, that won't hurt, and maybe a little common Lisp, and then come back and you know the awesome power of callcc. It's probably too powerful for most users, but sometimes it's really awesome, and in particular being able to get more than full-fledged coroutines. Generators are less than full-fledged coroutines. They're still the easy to implement, fast, and simple part, but callcc is more. So,
all right. Well, if that's all for questions, a hand for Alex Martelli.